Okay, so today we're going to look at the second part of conics, which is the ellipse. Okay, you have two different types of ellipse that are going to happen. We have one where the major axis is along the x-axis, which just means that it is going to be longer than it is tall. Okay, an ellipse is basically an oval-looking thing. That's what this thing should be. I know mine's not symmetric by any means, but that's what you're talking about. We also have an ellipse with the major axis along the y-axis. Okay, we also refer to this as vertical, or in the first one, if it's x-axis, it is horizontal. Okay, the x-axis is horizontal, okay, because it's horizontal, and the y-axis is vertical. So it will look something like such. Now these can be anywhere in these particular planes, but I'm just placing mine randomly. Okay, now with your ellipse, there's lots of little pieces that you have to know. For instance, starting with the center. Okay, this is the center, which is obviously the center. Okay, and our center is going to be HK, just like it is with our circles. So if you already looked at the circles, the center happens at HK. That's that coordinate point. Now we also have something called a major and minor axis. So we have a major axis, which goes through the longest part of the ellipse, right through the center of the circle there. Okay, or the center of the ellipse. This is called the major axis. Okay, it actually keeps going. We usually just draw it in the thing, but it technically keeps going. But this is your major axis. Okay, and we also have a minor axis, which goes vertically on our horizontal graph here. Basically, it covers the small end. Okay, so this is my minor axis. Now, the ends of these axes actually have names. So the end of the major axis are called the vertices. Okay, these are called the vertices. There's two of them, vertices. Okay, vertices is technically plural, so vertices, they're both vertices or a vertex. Okay, so you have your vertices. You also have, at the end of your minor axis, your co-vertices. Okay, you have co-vertices. Here and here are co-vertices. Again, vertices is really, it's plural, but co-vertices, okay, are what we're looking at there. They're at the end of your minor axis. So there's are your points. We also have one more important point, which you call the focus. Okay, and the focus is going to lie on the major axis inside of the ellipse. I mark mine with an X, but you don't have to. You can use a dot. It doesn't really matter. I just like to make mine a little bit different from my actual vertex. So I mark mine with X's just so I don't accidentally confuse them. But you can always just put little dots there. That's fine too. Okay, but they are called the foci. Okay, that is a foci. One there and one there. So I've got those. Okay. Got my two foci. Now, those are all the pieces. Okay, those are all the pieces. But you also have to consider the actual value or the distance of all of these things. Okay, because the distance is what we're going to use mathematically. If you see here, I've got a C, an A, and a B. Well, I've got to label those. So on here, if you talk about the distance from the center all the way out to the vertex, that is A. Okay, and if you want to make a little list, that's fine. That would be center to vertex. And then from the center to the co-vertices is your B. Okay, center to the co-vertices. Okay, and it's both of them. It's not just up, it's up and down. So both of these things would be B. These ellipses are very, very symmetrical. It's going to be the exact same distance up as it is down, same distance right as it is left. Okay, very, very symmetrical in that manner across each of those axes. They're very symmetrical. So I've got B up, B down, A right, and A left. And the last one here is the distance from the center out to the foci is our C value. Okay, so center to vertex is A, center to co-vertices is B, center to foci is your C values. Now, when you talk about your vertical one here, which we haven't labeled anything on, everything is going to be the same. Okay, the only exception to this is that on an ellipse, the largest axis is always going to be my major axis. So here, I've got this major axis, which is now going to be vertical, hence the word ellipse with major axis along the y-axis. Okay, it's going to be vertical. The longest length of this thing is going to go vertically. So now here's my major axis, okay, which still has vertices at the end. So now my vertices are top and bottom. Okay, vertices. There's 1 and 2 vertices. Okay, I also have my minor axis still, which goes through here. So here's your minor axis with endpoints of co-vertices, both sides. Okay, endpoints, co-vertices there, and I also have, again, that foci. Okay, you can dot or X, whichever you want. I'm going to X just because I like the X's. So there's your foci. The foci are always on that major axis. So notice they're running vertically now on my vertical graph. Other than that, from center to the vertex is still A. Okay, from the center to the co-vertice is still B. And oh, I didn't even write C. So from the center, notice they all start at the center, to the foci is your C, just like it is over here. Okay, so as far as vertical and horizontal goes, A, B, and C are always going to be the same, center to vertex, center to co-vertice, and center to foci. Okay, the difference is just which direction is it going. Here A goes up and down, here A goes across. So that's what you're going to be looking at. Now, the larger denominator denotes the major axis. This is super, super important. When you talk about the ellipse, okay, whichever has the biggest denominator is what controls the direction. Okay, so essentially if we have the bigger number below the X, then it's going to be horizontal. Okay, so that's that one up here on the top left. If the bigger number, and we'll talk about what we mean by bigger number, so if the big number is below Y, then it's going to be vertical. Okay, so big number below the X, it's going to be horizontal. Big number below the Y, it's going to be vertical. If I want to find my foci, I use this formula here. C squared is equal to A squared minus B squared. That's going to be given to you on the card that you get. Now here we're going to look just at ellipses centered at the origin, so around 0, 0. So we're not going to look at the plus HN plus K stuff yet. Okay, but we will get there, don't you worry. The only difference here between these two formulas is that here, A, which remember is the distance from the center to the vertex, is under X, and here A is underneath Y. Okay? So, going back to the fact that I said the bigger number below the X, A is always the largest number on an ellipse. Okay, A will always be bigger. And so if the bigger number is underneath X, then it's horizontal. If the bigger number is underneath Y, then it's vertical. That's what we're talking about. Okay, here I'm going to have a center of 0, 0 because nothing's added to X or Y. Now the foci is going to go along horizontally as well. So just the X value will change. So we're going to have C and negative C for my foci. These are just kind of little shortcuts. I'll show you how to use them in a little bit. The length of the major axis is always going to be 2A, and that should make sense because if you look here, the length from the vertex to the center is A, so from vertex to vertex is going to be 2A's. Okay? Simple as that. Same thing here. It's still going to be the length of the major axis is still going to be 2A. Alright, so the foci will always be inside of the ellipse and on the major axis. That's super important. If you somehow graph your foci and they end up outside of your ellipse, then you did something wrong. You either forgot to take the square root, or you put it on the wrong axis. Something happened, but it can't be outside of your ellipse. Now the A is always associated with the major axis. This is true when we're going to do hyperbolas as well. The A is always associated with the major axis. Furthermore, that means A is always associated with vertices. So if you want to make a little note of that also, vertices will always go with A, co-vertices will always go with B. Okay? So A always goes with vertices, because the vertices are the ends of the major axis. Alright, so let's look at how we actually use all of this information that I just rambled about. So starting with direction. If I want to determine direction, it's very simple. Find the biggest denominator. If it's under Y, it's vertical. If it's under X, it's horizontal. Simple as that. In this unit, Y means vertical, X means horizontal. Remember that. Okay, my center, I have nothing added to X, so 0. I have nothing added to Y, so 0. If you don't know what I'm talking about with the adding to X and Y, go back and rewatch the video for circles, because it's in there. Okay, A is always the bigger number, so we're looking at 25, but it's not 25. This here is A squared according to our formula that's up here. It's Y squared over A squared, so this is A squared, and this is B squared. So A is the square root of 25, which is 5. Okay, B is the square root of 9, which is 3. To find C, we use our formula, and you do need to show this in your homework. C squared is equal to A squared minus B squared. Okay, well, C squared is, we just said A squared was 25, and B squared is 9, which is 16, so C squared is 16, which makes C the square root of 16, which is 4. Okay, so C is the square root of 16, which is 4. So now, there's two ways you can go about doing doing your vertices, co-vertices, and foci. Most people like to just go ahead and graph. Okay, because I have everything I need right here to graph. So starting with a center at 0, 0, plot that point. This is a vertical graph. Okay, it's super important. The direction, the A, and the vertices all go together. So if I'm going vertically with A, so that vertically means up and down. So we go up 5, and you really just count. Up 5 and down 5. Plot those points. Well, those are my vertices, because those are my major axis. This is going to be the longest axis, which is going to be vertical. So up 5 and down 5. So I get 0, 5. And 0, negative 5. Okay, for those of you who are a little more mathematically minded and not so much pictures, all I'm doing here is, since it's vertically means Y, so I'm going to add 5 to my Y value for my center, so plus 5, so it gives me 0, 5, and subtract it, so minus 5. That's how I move up and down, plus 5, minus 5. Okay, that's how that works out. So I get 5 and 5, so then I write those coordinate points down. Co-vertices, same exact thing. Only now, if my major axis goes vertically, my minor axis must go horizontally. So now I'm going to go left and right 3 units. So right 3 units and left 3 units, and I write those down. Negative 3, 0, and 3, 0. And it doesn't matter. You can write 3, 0, negative 3, 0. You can switch them up. That's fine. You can't write 0, 3. That's different. Okay, negative 3, 0, and 3, 0. So put those two things down. Okay, if you were mathematically minded, I would be moving horizontally. Horizontally means X, so I would add 3 and subtract 3 from my center. Now, I've got those points, which you can barely see on that thing. Okay, but I'm just graphing those points there. And now, if I want to find my foci, okay, C is the distance from the center to my foci. Now, it's very important that your foci is always on my major axis, so it must move the same direction as A. So the same direction as my graph. So vertical, so I'm going to go up 4. There's one foci, and down 4. There's the other one. Notice these things come in twos, except for the center. So up 4 and down 4. So that is going to be, let me zoom in a little bit more so you can kind of see that a little better. Okay, so there are my focal points right there, foci. Okay, So now, as far as graphing goes, oh wait, we got to write down our focal point. So when x is 0, y is 4, 0, 4, and when x is 0, y is negative 4. So now I have all my points. Very last thing is that you have to actually graph this thing. And just like with your circles, I don't expect them to be perfect, but I do expect you to try and make them somewhat elliptical. So you need an ellipse type shape, okay? Oval-esque, okay? So make sure you try, don't just give me diamonds. I don't want diamonds. These are not diamonds, they're conics. All right. So looking at that second one, just to make sure we got it, I'm going to go a little bit faster. You can always pause it and go back again. My direction, biggest number is under x, so it is horizontal. My center is still at 0, 0, because there is nothing added to x or y. My a value, square root of 9, is 3. B is the square root of 4, which is 2. C is going to be, c squared is 9 minus 4. C squared is equal to 5. So C is the square root of 5, which is going to be 2.2. Okay, I'm going to do this graphically. So 0, 0. It's horizontal, so we're going to go right 3 and left 3, right down those points. So that is 3, 0 and negative 3, 0. And then we're going to go vertically with our co-vertices, so up 2 and down 2. Up 2 and down 2. Hopefully you can see that a little bit. So up 2 and down 2. And that gives me 2, 0 and negative 2, 0 for my co-vertices. And then for my foci from the center, I go out 2.2 and left 2.2, right 2.2 and left 2.2. They are on my major axis just outside the 2 there. So that's going to be 2.20 and negative 2.20. Again, if you're more mathematical, it's horizontal, so I added the a to the x value and subtracted it here. I did the co-vertice, I added to the, I wrote it down wrong. It's a good thing we went back and checked. Goodness gracious. That's not 2, 0, that's x is 0, y is 2. X is 0, y is negative 2. I didn't even write my points down. It's been a long day. So sorry. So for my co-vertices, I should have been adding and subtracting to my y value. So plus 2 and minus 2 to my y value. Good thing we checked. You'd have been yelling at me tomorrow in class. Alright, so then, let's double check the rest of this, make sure it's right. It is. Okay, so then 2.20, because I'm moving horizontally. So I'm going to add that to x and subtract it from x, which is what we have there. So last little step there. Do your best to make this pretty little ellipse. And there it is. Okay, mine's looking a little more potato-esque, but it's okay. I don't know why I keep saying that esque. Potato-esque. Alright. So that would be the end of that one. Again, you can always go back and rewatch that if I'm moving a little quick, but it is like 4:30 in the afternoon, and I've already done this a few times today. So, I'm going to kind of move quickly through it. Now, these two are going to be the two equations that you are going to have on your card. Okay, they're exactly like the ones on the front, only now we've included the x minus h and the y minus k. But if you've done your circles, this shouldn't scare you because this is just the center. That's all that is. Okay, so my new center is at hk. I'm still adding c to my x value, which is now going to be my h. For the foci, if I am on an x-axis, a horizontal one, and on a y-axis, we're going to add it and subtract it to my y value. Again, these are just kind of shortcuts. Okay, don't worry about them. They tend to confuse people more than they help them unless you really, you have that mathematical mind that you like the formulas. All right, so here, direction, we find the same way. Larger numbers under x, so it's still horizontal. Okay, my center, if you remember doing it from the circle, here's my x, it's x minus 1. Well, the formula says x minus h. Okay, so that means my h is technically just 1. Remember, we changed signs. So x is 1, or h is 1 rather, and k is positive 2. Okay, you change the signs when you pull them out. So there's 1, 2. Okay, my a, I find the same way. It's the square root of 4 is 2. The square root of 1 is 1. Okay, c is going to be c squared is 4 minus 1. C squared is equal to 3, which makes c approximately, let's see, the c is approximately, I think it's 1.7, but I'm not sure it is. It's 1.7. Okay, so 1.7 is my c value. Okay, so we're looking at 1.7 there. So now I'm going to do it mathematically this time, and then I'll show it to you graphically. So mathematically, I'm going horizontally, which means I'm going to add my a value to x. So I'm going to go 1 plus 2 is 3. Y stays the same. Okay, 1 minus 2 is negative 1. Y stays the same. This is very important, is that in every one of these three, one of those values should stay the same. So here, y is staying the same because it's horizontal, so the x is changing. Okay, on my co-vertices, we're talking about co-vertices, so now I'm going to keep my x the same. So I could even start off and write 1 and 1, and then figure out what my y value has to be. So I'm going to go up 1, so 2 plus 1 is 3, and I'm going to go down 1 from the center, so 2 minus 1 is 1. Okay, and I'm going to show you these in just a second graphically. So if you don't like this method, don't use it. You don't have to. There's never a time that you have to use this method. Even if we don't give you a graph to graph on, you could make your own graph and graph it out and still get your vertices, co-vertices. Okay, but some people like the mathematical method, so I'm going to go ahead and show it because for some people it's a little bit faster. Alright, so then the foci here, this is where that mathematical version tends to come in handy. I am still going horizontal because the foci moves the same direction as my graph. So I'm going to go 1 plus 1.7, which is 2.72. And I'm going to go 1 minus 1.7, which is negative 0.7, and 2. Y values stay the same there. Okay, now if you're doing that thing graphically, and I'm going to write, just for the sake of having the values seen in my picture here, B is 1 and C is 1.7, and I have a center 1.7 with a center at 1, 2. Just so you can see the information that I'm working with and you can actually read what's happening here. So start by graphing the center. So x is 1, y is 2, there's my center. Okay, when x is 1, y is 2, there's my center. And I know you don't really have lines on your paper, and I apologize for that. They didn't really print very well. So unless you printed it off yourself, then you might actually have lines. Alright, so then when x is 1, y is 2, so you get 1, 2. Now this is a horizontal graph. Okay, so if it's horizontal, that means my a value moves horizontally, so I would go right 2 and left 2. Right 2 and left 2. And if you look back at your vertices, okay, they match up. 3, 2 and negative 1, 2. Well, that's exactly where we are. 3, 2 and negative, that's 3, 2 and negative 1, 2. Okay, because those are all in a line. So, we're good there. Now the next part, we go up 1, and we go down 1 for those B values. It's going to be a tiny little bitty box, or little bitty ellipse rather. Okay, so I've got those now, and I would write those down, which would be when x is 1, y is 3. And when x is 1, y is 1. That should have been our co-vertices, 1, 3, and 1, 1. And then the last one here is our finding our focal points, our foci. Okay, so 1.7. So from the center, you go 1.7, which is going to be right here, right up against it. Okay, on both sides. It's real tight squeeze there. Okay, but right next to that one, because we're at 3 and 1.7 from there, it's going to be really close. Okay, but if you looked at this point, it's 1, 2, and then we know we went 0.7 over from there, so we've got when x is 2.7, y is 2. That's one focal point, and same thing here. So when I go right here, I know it was 0.7 because that's the fraction that I was using, so it's negative 0.7 when we're up at 2. So all of that is there. Make your cute little adorable little ellipse. He's so little. Okay? Cute little adorable ellipse. My focal points are on my major axis. They're inside of my ellipse, so we're doing good. And that would be the end of that one. Now, I'm going to skip over 4. It's kind of the same sort of thing. well, I guess I can put it down for you. So direction is going to be horizontal. Okay, the center is going to be at 0, -4, 0, -4. A value is square root of 36 is 6. B value is 5. C value is going to be 3.3. Vertices are 6, -4, and -6, -4. Co-vertices are 0, 1, and 0, -9. Focal points will be 3.3, -4, and -3.3, -4. Graphing this thing should look like such. So I have a center at when x is 0, y is -4, there's 1. When x is 6, y is -4, there's that point. -6, -4, there's that point. Try my best to make these things line up nicely. When x is 0, y is 1. When x is 0, y is -9. So there are all my ellipse points. When x is 3.3, which is here-ish, there's one focal point. -3.3 is there-ish. There's the other focal point. Draw your pretty ellipse, which is getting pretty close to circle, but still not quite a circle. Notice that the closer I get to the inside with my focal points, the closer I get to middle, okay, the closer it gets to a circle. In fact, if both of my focal points end up on my center point, then I would actually have a circle. Alright, so this next one looks a little bit different, okay, different because several things. All ellipses have to be equal to 1. If you look at every other one we've done, they're equal to 1, equal to 1, formula is equal to 1, both directions, everything's equal to 1. This is not. Okay? So that tells me, that right there should just send off little bells. Ding, 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 ding. Okay, can't have 144 there. We have to make it equal to 1. So if I want to do that, I just divide by that number. Divide by 144 for each little piece here. Okay, each term by 144. Well, 16 goes into 144 9 times. Okay, and you can use your calculator. 16 and 144 goes 9 times. So you basically reduce to 1 over 9. Okay, 9 goes into 144 16 times. So now I've got y squared over 16, which is all equal to 1. Okay, all equal to 1. So I've got x squared over 9 plus y squared over 16 equal to 1. So that plus sign in the middle, that tells me that this is an ellipse, by the way. Okay? That is an ellipse because it is adding two of these things together, and the denominators aren't the same. If these two things were the same, well, then I'd have a circle, because that means my minor axis and my major axis would be identical. Okay, if my minor axis and major axis are identical, that makes this thing a circle. So please keep that in mind. If you somehow end up with two denominators the same and it's equal to 1, well, that means it was a circle to start with. Alright, so x squared over 9 plus y squared over 16 equal to 1. So the direction here, after this point, it should be really easy. It's the same stuff we've been doing. Vertical because it's under y. Center is at 0, 0. A value is going to be 4, the square root of 16. Okay, make sure you're going with the biggest. The B is the square root of 9, which is 3. C is going to be the square root of 7, which is 2.6. Okay, because c squared is equal to 16 minus 9, which is 7. So the square root of 7 is 2.6. So vertices, this thing is vertical. So we will add and subtract to the y value. So we get 0, 4, and 0, -4. Co-vertices are going to go horizontally. So we'll get 3, 0, -3, 0. And the foci are going to go vertically as well. So you'll get 0, 2.7, and 0, -2.7. Okay? Again, you don't have to do it this way. You can always just graph. So we're going to go 0, 0. And we are going to go vertically 4, up 4, down 4, write those points down, 0, 4, 0, -4. We're also going to go horizontally 3 units, because that's my B value. 3, 0, -3, 0. And then 0, 2.7, and -2.7 are my nice pretty little focal points there. So I'm going to draw those in. Even though I don't really use them to make my graph, I still need them there. They're super important when you talk about ellipses to understand the focal points, the foci, okay, because those foci come in very, very handy. When you talk about an arena or something of that case, if you were at the focal points, then sound's going to travel the best. In fact, they say that there are certain Roman cathedrals that if you stand in them, they're shaped in such a way that if I were to drop a pin at one end of it, you could hear it if you were standing on the focal point on the other end of the building. So it's kind of cool little tidbit of information. I've never been to Rome, so I really couldn't tell you that, but that is what they tell me. So, alright, we got a couple more, and this is not going to be your favorite, I can already tell you that, but it's not really that bad. It's all stuff that we have learned in the past. So we already looked the other day at circles with doing complete the square. Okay, sometimes you're going to have to do that with your ellipses as well. This one's got a little extra kick to it because I've got a number in front of x squared. And if you remember back to doing complete the square, we can't complete the square unless there is a 1 in front of my squared variable. So start by putting these things together. So I've got 16x squared plus 64x. By the way, what told me I needed to do this complete the square is that I have this extra x and y sitting over here. Okay, if I didn't have an x and a y, I wouldn't have to. I would just divide everything by 576, just like I did on the last page. Okay, here I had the number out front, 16x squared and 9y squared equal to 144. But I just had an x squared and y squared, so all I had to do is divide. Here, it's not the same thing. I've got an x squared and a y squared, but I also have an x and a y. So before I can divide by anything, I have to complete the square. So please keep that in mind. Okay, so now we've got plus 36y squared minus 72y, all equal to 476. My screen froze, hold on. And I seem to have hiccups. Okay, so that's a lot of talking really quick, makes my mouth dry. Alright, so here, before I can complete the square, I must factor. We're going to look at these things separately. Whenever you're doing complete the square, look at the x's by themselves, look at the y's by themselves. Don't try to look at them all at the same time. Okay, so here are my x's. I can take a 16 out. Little hint to you, it will always be the entire number in front of the squared variable. It has to be, otherwise you can't complete the square. So I get x squared plus 64 divided by 16 is 4x. Okay, we are factoring here. That's why that 16 comes out front. And then plus, I'm going to leave my space for completing the square. Okay, let's go ahead and do the same thing here with my y value. So plus 36 is going to factor out. I'm looking at just y's. So 36 comes out front. I'm left with y squared. 72 divided by 36 is negative 2y. And we're going to leave our plus blank here equal to 476. Now before, we usually do just plus blank and plus blank. That's not going to work exactly like that this time, because I'm not just putting in a number here. I'm putting in 16 times that number. So when I do a plus blank, it actually has to be 16 times blank. Okay? 16 times blank. Okay? And then I also, and again, the blank is so I can complete the square. I'll show you how to do that in a second, just in case you have forgotten, although this was from chapter 9, so, or unit 9 rather. Okay, so now we also have 36, I didn't leave myself enough room, so plus 36 times another blank, because it's going to be 36 times whatever I put in that blank spot. Okay, so how do I figure out what to put in the blank spot? Well, we did this in circles the other day. You take half of the middle, so the number by x, so 4 over 2 squared is 2, 2 squared is 4, so add that in and do it to both sides. Okay, do the same thing here. You take half of the middle, so half of the number by y. You square it. Negative 2 over 2 is negative 1. Negative 1 squared is positive 1. Put that on both sides. Okay, now on the left-hand side, I still have a 16. And I'm going to factor x squared plus 4x plus 4. Okay, it is going to factor to half of the middle, x plus 2 squared. If you aren't comfortable with that, target product, target sum that thing. X squared plus 4x plus 4. My target product is 4. Okay. Target sum is also 4. So what two numbers multiply 4 but add to 4? 2 and 2. So this thing would become x plus 2 times x plus 2, which is x plus 2 squared, which is what we had. It's nice if you know the shortcut, though, that it will always be half of the middle. Okay, and that's the shortcut that I'm going to use, because otherwise we'll be here all day. Y squared minus 2y plus 1, so this is going to go half of negative 2 is negative 1 squared equal to. Now just multiply and add this stuff up. Okay, 16 times 4 plus 36 is 100, plus 476 is 576. You can use your calculator to plug all that stuff in. Okay, and now I'm at the point where now I've got an x squared and a y squared, but I'm still not equal to 1. So now, just like we did on the other page, I can divide everything by 576. Okay, I no longer have that extra x and the extra y. I've condensed all of that into my factored little form here. It's all a perfect square, and we love it. Divide this stuff out. Okay, so 16 into 576 just so happens to go 36 times, I'm so sorry. Please keep in mind that you're not going to get anything crazy. We will not give you numbers that don't work out nicely if you're going to do something this long and drawn out. So, these numbers should go in evenly. 36 into 576 is 16, all equal to 1. So now that we're at this point, you can go ahead and you can find all the rest of your information. So direction is horizontal, because the big number's under x. The center is at negative 2, positive 1. A is going to be 6. B is going to be 4. C is going to be the square root of 20. Okay, because c squared is 36 minus 16, which is equal to 20. So the square root of 20 is 4.5. Just want to make sure I was correct before I wrote it down. Okay, my vertices, I'm going horizontally, so I'm going to add 6, so negative 2 plus 6 is 4. Keep the y the same. Negative 2 minus 6 is negative 8. Keep the y the same. Co-vertices, we're going to keep x the same this time, and 1 plus 4 is 5. And negative 2, 1 minus 4 is negative 3. And then my focal points will come to, it's 4.5. So it's going to move horizontally, so we're going to go with the x again. So we're going to go negative 2 minus 4.5 is negative 6.5, 1, keep y the same. And then negative 2 plus 4.5 is 2.5, keep 1 the same. Okay, now the only thing you have to do with that is to go back and graph all of that wonderful stuff, or you may have already graphed it. X is negative 2, y is positive 1, make that center. Okay, we're going to go right 6 and left 6. We're going to go up 4. Can't see the points anymore. Up 4 and down 4. Up 4 and down 4, throw my focal points in, so we're going to go right 4.5 and left 4.5. Got all my pieces, just draw my ellipse. Okay, draw your little ellipse, focal points are inside, we did an awesome job, that's fantastic. Alright. So, 2 more. We're almost there. This is kind of a long lesson, I know. We actually skipped over a few of them in the notes, so if you did this by video, then you got a little extra help, which is always good, right? Everybody loves extra help. Alright, so I want to look at this one because I've got 25x squared plus 9y squared plus 72y minus 81. So something that should point out is that we've got that extra y. What I don't have is an extra x. What that means is that I will not do completing the squared with the x. You don't have to complete the square twice, okay? Sometimes you're just going to complete the square once, which is what we're about to do. But before I can complete the square, I want all my variables on one side. I also want all of my numbers on the other side, because that's going to get in the way of my completing a square, making it perfect. Now, if you remember back to completing the square, you've got to move those numbers over first. So I get plus 9y squared plus 72y equals 81. So, again, we're going to leave that x alone for now, and we're going to factor. We're looking at just this. We want to complete this square so we can make it pretty. So, factor out the 9. We get y squared plus 8y plus blank equals 81 plus 9 times blank. Okay, we got to figure out what to go in the blank. Notice I didn't do anything with the x. I didn't add anything for the x because I'm not adding anything here. If I'm not adding it here, I don't add it here. Okay, as long as I do whatever I do to this side, I do to this side. Well, I'm going to add the blank stuff. So, adding the blank, half of the middle. 8 over 2 is 4. 4 squared is 16, so that's what I'm going to put in there. But it's not just 16, it's 9 times 16. Both sides. And then we're going to factor that. So I still have 25x squared plus 9 times y plus 4 squared. It's always half of the middle. Half of 8 is 4. Equal to, that's going to be 225, and you can use your calculator and figure that out. Okay, and now I'm to the point where I can divide. So we're going to divide everything by 225. 225 and 225. Which, what do you know, is going to divide perfectly. So x squared over 9 plus y plus 4 squared over 25, all equal to 1. Okay, from there, just pull your information. Again, going quickly. Vertical. Center at, there's nothing added to the x, so that's 0. I do have a plus 4 here, so it changes to minus 4 on my y. My a values, the square root of 25 is 5. B is the square root of 9, which is 3. A is always bigger than B, if you haven't figured that out by now. Okay, with the ellipse, A is always bigger than B. Okay, so A is 5, B is 3, C is 4. C squared is 25 minus 9, which is 16. Vertices. Okay, my vertices. So let's do this graphically this time. We haven't done that in a while. Okay, so my center is at 0, negative 4. My A is 5, and it's a vertical. Okay, so if I'm going to go vertically 5, so we're going to go up 5 and down 5. Write those 2 points here when x is 0, y is positive 1, 0, 1. Can't really fit them both on the same screen and have you still be able to read it. Down here, when x is 0, y is negative 9. So 0, negative 9 is my other vertices. So then co-vertices, we're going to go left and right from my center 3 units. Okay, because B is 3. So we're going to go right 3 units. And then left 3 units. Looks about right. Okay, right 3 units and left 3 units. So that's going to be at the point. Okay, this one is when x is 3, y is negative 4. So 3, negative 4. And when x is negative 3, y is negative 4. So negative 3, negative 4. And my foci, I need to go 4 from the center vertically. Okay, so C is equal to 4. We're going to go 4 up and 4 down. Okay, because it's a vertical graph. So then mark those points. That point right there is 0, 0. And that point right there is x is 0, y is negative 8. 0, negative 8. Okay, so when x is 0, y is negative 8. So that is going to be all of those awesome points, and then you just need to make your little ellipse. And we just have one more to go. Alright, so you have to be able to look at a graph and pull information. Now I'm going to have to back out so we can look at this all at once. There we go. Okay, so you have to be able to look at a graph, and you're going to have to pull information from it. Now, this has got faded lines, but you can still do it. You'll be able to tell where things are. So starting with direction. This is obviously longer than it is tall, so it's got a horizontal direction. Horizontal. Now the center, you need to find the center. Okay, and it looks right about there. It's going to be in a perfect spot. I'm not going to put them at decimals. So there looks like the center. So I'm going to go with x is 3, y is positive 2. That's my center. 3, 2. Okay. Now, my A value. A is to my vertices, so all I have to do is count from here to here. Okay, that's my vertices. So if I'm at 3 and I go over to 8, well, that's 5 units. Okay, 5 units. 1, 2, 3, 4, 5 units is how far I traveled. Same thing with B. If I start here at 2 and I go up to what looks like 5, because again, I'm not going to use any decimals, so we went up 1, 2, 3 units. So B is going to be 3. C, I'm going to find the same way I always do because they didn't graph it for me because they didn't want to. So C squared is equal to A squared. Be careful here. A squared is 25 minus B squared is 9. So C is going to be 4 because that's 16. Sorry, skipped a step. C squared is 16. Square root of 16 is 4. So C is going to be 4. I'm going to go ahead and graph those. So from my center, if I go over 4, puts me there and there. And I'm just doing that so it makes it easier on myself when I go to write down all of this stuff. So writing down the vertices, you just have to know which one are the vertices. I know that this is my vertice because it's on my major axis. This is the longest side. Okay, so these are my vertices. So that vertice, when x is 8, y is positive 2. And this one, when x is negative 2, y is positive 2. Again, we're just assuming that they're all going through nice pretty points. We're not giving you decimals for any of that stuff. Okay, co-vertices. So this point here, when x is 3, y is positive 5. And when x is 3, y is also negative 1. And then my focal points. So when x is 7 is this one. Y is 2, and when x is negative 1, y is 2. So this is just finding all this stuff on the graph. So negative 1, 2, 7, 2, I have 8, 2, and negative 2, 2 for those, and co-vertices there and there. Now the equation. So the last thing I got to write up there is the equation. Okay, so starting with, do I have a center? And I'm going to write it down here just so I have more room. Okay, my center, I've got x minus 3 squared and y minus 2 squared. And this is just typically how I do it. You don't have to do it this way. You can go left to right. Okay, I know it's an ellipse, so it's got a plus sign. And I know it's equal to 1. Okay, so then here, this is a horizontal graph. So the A value squared needs to go under the horizontal, which means under the x. If this thing was vertical, I would put the big number under y. But since it's horizontal, big number under there, but you have to square it. So 5 squared is 25. And underneath y is going to be the b value squared. So 3 squared is just 9. All equal to 1. Everything is squared. I got my center. Okay? And you should be able to double check. If I were to take this out, my center would be 3, 2. Okay? It would be horizontal because it's under x. The A value would be 5, B value would be 3, so you could kind of double check it to make sure that you have it right. And that is the end of ellipses. I know that was a little long, and I know that those completing the square ones are a little difficult, but I would suggest going back, looking at them again. You could probably even print out another copy and see if you can do it all by yourself, and then look at what I did. Okay, good luck.